Hello and welcome to another episode of Geography Made Easy. In this video, we will be trying to make difficult geographical topics easy. In today's topic, we will be discussing the climate of India and how it influences the lives of the people of India. India has a monsoon type of climate. And this monsoon is not just reflected in the daily lives of the people of India, but it is present in literature, art, and other forms of expressions where monsoons come into play. Monsoon has been derived from the Arabic word mosam, which means a seasonal reversal of wind. This is a unique phenomena which occurs in the Indian subcontinent, and this is studied not just in the Indian context but in the worldwide phenomena. Before we understand about the monsoon climate, first we have to understand the factors which affect India's weather and climate. The first and the foremost factor which affects India's climate is its location and latitudinal extent. India roughly lies between 6 degrees to 37 degrees north latitudes, as seen in Chapter 1. The Tropic of Cancer passes through the middle of the country. The southern part of the country is closer to the equator and it experiences very high temperatures throughout the year. The northern part, on the other hand, lies in the warm temperate zone. And because of the presence of lofty mountains and sea, the climate of the northern part of India gets modified. So the vast latitudinal and longitudinal extent of the country has a major impact on the climate of the country. The next point is distance from the sea. The peninsular part of India is surrounded by three seas and oceans: the Bay of Bengal, the Arabian Sea, and the Indian Ocean. The presence of the water prevents the coastal part of India to experience extreme type of temperature, that is too hot or too cold. So we see that the coastal areas and the southern part of India experiences moderate type of climate. The third part is the northern mountain ranges or the Himalayas. The Himalayas and some of these adjoining mountain ranges which are occurring in the northern part of the country to the northeast and northwest. So from Arunachal Pradesh to Kashmir, we see these mountain ranges. They regulate the climate a lot. These mountains protect India from the bitter cold and dry winds of Central Asia. So India would have otherwise been very cold during the cold season, but the Himalayas act as a barrier which prevents the cold air of Central Asia from coming into the Indian subcontinent. Similarly, these mountain ranges also play an important role for effectively creating the monsoon mechanism. Thus, the Himalayan mountain ranges as well as the other mountain ranges in the north play a very important role in determining the climate of India. The next point is physiography. Physiography means the physical form of the country, and we have discussed in details in the previous chapter about the different types of physiography that exist in the Indian subcontinent. The physiography of the country influences other climatic factors such as air temperature, atmospheric pressure, direction of wind, and amount of rainfall. So where we see that mountain ranges are there, the amount of wind blowing in that area, the kind of rainfall that is experienced in that area, which results in the temperature changes and the pressure, is all linked together. And the presence of one physiographic unit is having an impact on all these other climatic units. Let us take the example of the Thar Desert. The Thar Desert is very dry, so it lies somewhere here, the desert. So the desert area usually experiences low pressure in the summers, and the winds do not bring in a lot of moisture into this area, hence they are cold and dry. So, and experiences very extreme temperatures, that is very hot in the summers and pretty cold in the winters, as well as diurnal changes in temperature, so very hot in the daytime and very cold in the night time. So the presence of this kind of a desert area without any mountain range, which is lying parallel, which without any mountain range, which is creating any kind of rainfall in this area, has a direct impact on the kind of climate we see for this particular physiographic unit. The next is the monsoon winds, which separately will be studied as a very important component. So the complete reversal in direction of winds during the summers and then after the summers during autumn creates a different kind of a unique kind of a phenomena which brings in a lot of rainfall to the entire subcontinent. This enhances or changes the climatic condition of the Indian subcontinent, making it much more easier for plants and animals to survive on this area. So monsoon winds very have a very major role in determining the weather and climate of India. Next, we have the upper air circulations. So wind, it not just blows on the surface of the earth, but it blows a few kilometers above the earth as well. These winds are known as upper air circulations or also jet streams. They occur around 10 to 12 kilometers above the surface of the earth. That is just after that we encounter the ozone layer and the stratosphere ends and another layer of the atmosphere starts. So these jet streams help in conditioning the surface weather of India, bringing in different kinds of moisture laden winds from other parts of the world into the Indian subcontinent, and we will be dealing with the jet streams and the role of jet streams in monsoons in much more details in the next few slides. Next we have the western disturbances and the tropical cyclones. Western disturbances occur during the winter season. Western disturbances are bad climatic conditions which are actually occurring over the Mediterranean, and these western disturbances come to the Indian subcontinent by the help of jet streams which pull these bad weather into the Indian subcontinent. These western disturbances actually bring in a lot of rainfall in the western part of the country in this area. Here we see that wheat cultivation is done in the winter season, and the presence of the western distribution actually helps in the wheat cultivation. So this also has a huge impact on India's climatic conditions. Tropical cyclones occur in the Arabian Sea and Bay of Bengal, usually during the months of April, May, and sometimes in the autumn months of October, November. These are intensive low pressure cells which build up due to the building up of heat in the oceanic surfaces, and we see that around this very intense low pressures a high pressure cell develops, and this leads to winds blowing at a great speed from high pressure to low pressure. I hope you remember that winds always blow from regions of high pressure to regions of low pressure, because if we imagine winds, they occur just like in case of rivers. So high pressure zones are zones which have a lot of wind density, or lot of wind is there, and low pressure zones are zones which have less wind, so if I or less air molecules. If I have to consider or give the example of two jars of, say, two jars of same volume, the one which has 90% saturation of air will have a higher pressure compared to the one with 60%. So the volume of both the jars can be the same, but the one which has more percentage of air inside will have higher pressure, because air pressure is the pressure which is exerted by column of air on the surface of the earth. We have done this in class 11, just a quick recapitulation. So winds always, when there is high pressure, there is excess of air in that area. Where there is low pressure, there is less amount of air. So winds blow from high areas to low areas, high pressure zones to low pressure zones. Just like we see in case of water which flows from zones of elevation to zones of less elevation. So similarly, in the same manner, wind is a fluid, it behaves in the similar fashion. So these intensive low pressure cells around which we see that high pressure cells develop, very high wind starts blowing and tropical cyclones develop. Now these tropical cyclones bring about a lot of change in the weather pattern of the country. They are resulting in a mass scale destruction. They bring about a lot of rainfall, and they completely change the climatic situation of a particular place during a particular time. Next, we have the El Nino effect. The El Nino has, as well as we'll do these two together, El Nino and southern oscillations are our upper air circulations, our presence of presence of changes in the sea water temperature, the presence or the absence of particular ocean currents, which lead to the change of the atmospheric conditions, which have an effect in a delayed or an early monsoon. So I don't want to go into too much of details about El Nino and southern oscillations here, because they are not too important, because this question, if it comes, it can come as a 5 mark or a 3 mark question. So the first few points itself are very important, and if they are explained properly, they should fetch you marks. But just to know what El Nino is, El Nino is a particular kind of an ocean current which occurs off the coast of Peru, whose presence and absence determines whether there will be drought or flood conditions. And this particular presence of this particular the particular current determines the weather conditions of other parts of the world as well, because all the weather conditions which we see are linked together, because the atmosphere is a single system. So we, just like we take into the account that global warming is a mass scale phenomena, similar, this is just because of the fact that if my global emission of pollutants is taking place in one part of the world, it is going to affect the entire world as a whole, because the entire atmospheric system is not in parts but is one planet, and it is a one system which is affecting the entire world as a holistic, in a holistic manner. So one needs to be careful. So also we see this El Nino tells us about the fact that this is very very important and needs to be taken into consideration. Southern oscillations are meteorological changes which are observed between the Indian and Pacific Ocean. On the contrary, low pressure conditions exist in the southern part of the country. So sometimes low pressure depressions, which are called as the western disturbances, they travel from the Mediterranean to northern part of India, bringing with it bad weather and rainfall. So the wheat cultivation and the agriculture which is seen in the northern part of India, where we see the rabi type of cultivation is practiced, we see that this benefits from the rainfall which is received by the western disturbances. Not much rainfall is caused in other parts of the country. However, some rainfall is also seen in the southern coastal states. We look at the isotherm maps. Here we have the average temperature zonation situations during the winter. So the average temperature is 10 degrees Celsius in the northern plains and the Himalayan mountains. So this is the average temperature. In certain parts, the temperature can become as low as minus 0, 1, 2, and much more lesser in the high altitude areas. An average of 15 degrees mean temperature is seen in parts of Rajasthan, and this passes over parts of northeast as well. In the middle part of the country, we see that around Gujarat, Maharashtra and Orissa, West Bengal, an average of 20 degrees Celsius is experienced and the winter temperatures are not too harsh. As we move towards the southern part of the country, especially in the coastal areas, we see that up to an average of 25 degrees Celsius is experienced in the southern part of the country. High pressure, as we have already discussed, exists in the northern parts of the country, north and northwest here. And most of the other parts of the country are experiencing low pressure. So wind, we know, blows from region of high pressure to regions of low pressure. So we see wind blowing from the north and the northwestern part of India towards the south, and not much rainfall is received during this time period. Next we move on to the next season, which is the summer season. The summer season in India is between April to June. The temperatures start rising from mid-March, and this can go up to 45 degrees to 55 degrees Celsius in northern and northwestern part of India, especially over the Thar desert and central India, northern plains. In the north and northwestern part, we have very very hot winds which are called Lu. So they blow on a daily basis, and this hot wind does not bring any relief to the countryside. Rather, it makes the heat very oppressive. The south has comparatively less extreme temperatures due to proximity of the sea, but because of the presence of the sea also, the moisture content remains high in the coastal areas. But extremities are not experienced. Temperature remains high because of the entire subcontinent lying very close to the equator, but it doesn't become as oppressive as in North India. If you look at the pressure distribution, the northern plains and the desert regions experience low pressure conditions. So we see during the summer months the pressure conditions slowly starting to reverse, and we see the entire setting for the northwest monsoons to come into the subcontinent getting formed in the summer months. So the the temperature and the pressure conditions which are required for the monsoon to set in is beginning uh, to get ready from the summer season. The southern parts of the country experiences higher pressure. Rainfall is varied and scattered over the entire subcontinent, bringing relief to certain parts of the country with the help of local storms such as Kalbaishaki or monsoon or mango showers. So we have different local names for these local storms in different parts of the country, which bring temporary relief to the areas which are experiencing. So these rainfalls are caused when a particular area experiences very high temperature, which leads to the formation or rapid formation of tall towering clouds, and because of these tall towering clouds, condensation sets in and we see rainfalls of pretty violent rainfalls, in many cases thunderstorms with thunder and lightning taking place in some parts of the country. The best example I've already said is the Kalbishaki, which is seen in West Bengal. So I'll just give some names of this. The local storms are called the mango showers or the blossom showers in Kerala, because the showers, the rainfall from these thunderstorms actually help in bringing about the mango fruits for their formation. It is called Nor'wester. It's called Kalbaishaki in West Bengal or in undivided Bengal, and Bardoli Chira in Assam, and in Lu in Punjab to Bihar, actually in the entire northern plain. So we have the Lu winds, which are hot and dry. So these are the thunderstorms which bring in rain. But Lu is not bringing in rain, it is a dry wind. The winds, sometimes we see dust storms occurring in the northern plains, which are known as the Adhi. Adhis sometimes can bring about rainfall, and they are cold winds, and locally they are seen in Delhi, Uttar Pradesh, Bihar and surrounding areas, again where the moisture content is low. So this is the mean temperature and pressure map for the summer seasons. So we have the dark lines, which are the pressure. We can see that the low pressure zones are developing, it is getting reversed. So low pressure zones are developing over the western part and northern part. And we see comparatively higher pressures are getting developed in the entire subcontinent. The lighter colored lines are denoting temperature, and we see that temperature is very high because the central part of the country is experiencing extreme continental type of climate. We see that the average temperature becomes very high in the summer season and becomes quite low in the winter season. So this contrast is very high between the summer and the winter. For example, if we have Delhi, which experiences up to 50 to 55 degrees Celsius temperatures in the summer seasons of May, whereas in December January it was experiencing 0 degrees to 2 degrees of temperature in the cold season. So the extremity of temperature is very high. We have a very high summer season, we have a very low summer season. So any part, any place which is in the middle of the country, which is in the continental region, will experience such extremities. On the other hand, if we take the example of Chennai or we take the example of Mumbai, we will see that these places are experiencing maritime climate. That means that those summer temperatures can go as high as 35 to 40 degrees Celsius, the winter temperature also does not become 0, 1 or 2. It is 27 degrees Celsius. So the difference between the highest temperature and the lowest temperature is less. So it is less oppressive. It's much more pleasant to live in this part in Chennai than it is to live in Delhi. Now we move into the most important season of the climate of India, which is the monsoon season. The monsoon season starts in June and ends in October. Actually, it doesn't end in October. It continues with the retreat or the withdrawal of the monsoons. So when do we say that the monsoon season has started? During the summer seasons, the extended summer seasons, all of a sudden we see that rainfall starts in parts of India. This is known as the burst of the monsoon because the monsoon in India occurs all of a sudden, just like it's a surprise for the people of the country. That is why it is called as the burst of the monsoon, and we will be discussing in details about the mechanism by which the Indian monsoons blow from the across the subcontinent. So monsoon winds basically gets divided into two currents, the Bay of Bengal branch and the Arabian Sea branch, and we will be discussing them in details. We will start to understand the way in which the Indian monsoons function with the help of the two branches of the monsoon winds. So, because of the peninsular shape of India, we see that the monsoon winds divides into two branches. So, the first branch is the Arabian Sea branch, and the other branch of the monsoon is the Bay of Bengal branch. So I'll use these different colors to denote the two branches. So the southwest monsoons usually blow from the oceans towards the land. They develop when we see that low pressure conditions are developing over Thar Desert and in the Tibetan Plateau area. These low pressure cells are intensive and they attract from the high pressure which is developing around the seas. The winds from the oceans travel towards these low pressure cells. So when the monsoons which actually originate in the southern hemisphere, because of the Coriolis effect, they get deflected and they blow from the southwest direction. So if we have to understand direction, we have north, south, east and west. So this is my southwest direction. So winds are usually named from the direction from which they blow. So southwest monsoons blow from this direction. And because of the peninsular shape, as we have discussed, they get divided into two branches. The first branch is the Arabian Sea branch and the second branch is the Bay of Bengal branch. Now we'll talk about the journey of the Arabian Sea branch. We know that we have the Western Ghats on the western parts of the Indian subcontinent, the coastal areas, and we have the Aravallis around here because these two mountain ranges play an important role, and we have the Himalayas on the northern part. Now, what happens is we see that the western part of the Western Ghats receives extensive rainfall. And when these winds they cross over and they move towards the plateau area, this portion of the Deccan Plateau falls in the rain shadow region, of the Western Ghats. So, if we have two places, for example, Mumbai will receive more rainfall than a place which lies in the Deccan Plateau area. So, Bhopal will receive less rainfall than Mumbai, which is lying on the western side of the Western Ghats, because it is encountering the heavy rainfall from the rain-bearing clouds. Now what happens is this wind is blowing across Gujarat and towards the low pressure it is getting attracted, but sadly there is no mountain range which is perpendicular to the Arabian Sea branch. If there was a mountain range which was perpendicular, then there would have been intensive heavy rainfall and Thar desert would become wet. But we do not see this because the Aravallis are parallel to the Thar deserts. We see that the rainfall is scanty, and hence we see that the Thar desert is a desert which receives scanty rainfall. Finally, we see some amount of rainfall in the Shivalik ranges where the Arabian Sea branch is encountering the Himalayas. So the southern slopes of the Himalayas receive high rainfall. Now let us go to the Bay of Bengal branch. The Bay of Bengal branch, we know that it has bifurcated. So this is the path which the Arabian Sea branch was taking. The Bay of Bengal starts blowing over the Bay of Bengal. When it is encountering the eastern coastal plains, it is receiving some amount of rainfall because of the moisture which has been collected from the ocean. Now this particular wind directly goes and it hits the Meghalaya plateau. Now we know two of the most wettest parts of the earth is located in the Meghalayan plateau area. So we have Cherrapunji, which was actually initially thought to be the wettest part or wettest place on the earth, but now it is Mausam Gram, which is receiving the maximum amount of rainfall. So this rainfall, so the rain bearing clouds, they directly hit the Meghalaya plateau area, and extensive amount of rainfall is received in the eastern Himalayas. This is also one reason why the eastern Himalayas are much more wetter and moist than the western Himalayas. Now, once the Bay of Bengal branch is encountering and a lot of rainfall is happening in the Meghalaya plateau region, it starts bifurcating towards the northern plains. So we see Assam receiving very heavy rainfalls. Then we see the winds are moving over Sikkim, North Bengal and West Bengal, East Bengal as well, that's Bangladesh. And then it starts to blow over the northern plains, and we see that the northern plain receives heavy rainfall. But as the wind is moving from away from the oceans towards the inland, we see that the precipitation amount reduces because the moisture is getting depleted. So finally, when it is going to the Aravalli ranges, we see that Aravallis are parallel to perpendicular to the Bay of Bengal branch of monsoon winds, but we see that it still does not cause a lot of rainfall because the amount of moisture in the wind has become less. So Kolkata will receive more rainfall than Patna. Then Patna will receive more rainfall than Lucknow. Lucknow will receive more rainfall than Delhi. So this is the way in which this Bay of Bengal branch of monsoon wind moves, causing rainfall. So we have discussed briefly about the ways in which the two branches of the monsoon winds they operate. Now there are a number of theories which have tried to explain the mechanism behind the Indian monsoons. So we have basically three theories. The first one was given by Edmund Halley, which is a very old theory. It is also known as the classical theory, which tries to explain monsoons. So it was initially believed that monsoon has been caused by the differential heating of land and sea. So that is why a low pressure is developing over the land and a high pressure develops over the ocean, and because of the difference, winds blow from region of high pressure in the oceans towards the region of low pressure in the continents. To this could not explain the entire mechanism, so Flon puts in more information and modifies the Halley's theory, and he talks about the seasonal shift of pressure and wind belts, which is also known as the apparent shift of the sun. So because of the apparent shift of the sun, the seasonal pressure and wind belts they move, which leads to a migration of northwards and southwards of the wind belts, which is the trade wind belts, which is moving. So that is the reason why the southwest monsoon winds, which are very strong, are occurring. However, the modern theory given by Flon Koteshwaram takes into account all of that which has been discussed previously, that is the differential heating of land and sea is considered important. Along with that, seasonal shift of the ITCZ or intertropical convergence zone is also considered to be important, and additionally the role of jet streams has been acknowledged in monsoon mechanism. So with time, these monsoon theories have been revised, and we have the constant monitoring of the monsoons with better equipments, which has enabled us to understand the monsoon mechanism a bit better. So in the present day, it is the IMD or the Indian Meteorological Department is able to predict the monsoons quite accurately, whether the monsoons will be heavy or whether the monsoons will not provide sufficient rainfall, and this has been because of the development of the technological know-how in the present day. I will try to explain the monsoon theories with the help of the map of India. So we'll start with the classical theories, or the theory given by Edmund Halley, where he talks of the development of low pressure. So he talks about a low pressure development in the Thar Desert and western part of India, and a low pressure developing over the Tibetan Plateau. Now these low pressures are very intensive. On the other hand, we have high pressure cells developing over the Arabian Sea, the Bay of Bengal and the Indian Oceans. So we know that winds blow from regions of high pressure to regions of low pressure. So this is the reason why wind will tend to blow in this direction towards the low pressure centers. Now this leads to the generation or the beginning or the mechanism of the monsoon winds, which Halley understood as to have caused the monsoons. Now Flon came and he modified this theory with bringing in the equator and the apparent shifting of the sun. But this is known as the westerly jet stream. So during the winter months, we see the westerly jet stream blowing over the Himalayas and the Tibetan Plateau. What happens in the summer seasons is that this westerly jet stream gets pushed beyond the Tibetan Plateau, and we see it getting replaced by the easterly jet stream. This easterly jet stream is responsible for bringing in the monsoon winds in this direction. So this jet stream or the upper air wind actually attracts the surface wind into the Indian subcontinent. Now I'll just discuss that how the two winds, the upper air winds, are actually it in a way it is related to the surface winds. So we have, if I look at it in a three-dimensional manner, so this is my ground and this is my upper air atmosphere. The jet streams blow in this manner. They blow in the form of loops. Now, because they flow in the form of loops, these parts or one portions of the jet streams, they are known as my limbs. Now, these limbs actually act as vacuums, or just like in case of a vacuum cleaner, where we see that the air is sucked in or the air can be sucked out. Similarly, the jet stream limbs also act as vacuum cleaners. So when air is getting sucked in, we see that there will be movement of surface, so there will be a vacuum which will get created on the surface of the earth, and winds will get attracted towards this portion, because constantly the upper air is pulling the air from the surface. And when we see that the wind, there is excessive of wind and it is getting pushed down, we will see that this leads to wind getting dissipated from the center. So this is the way in which the jet streams function. So the westerly jet stream is a jet stream limb which actually behaves in this manner, which creates the high pressure zone. High pressure is created when we have excess of air, excess of usually cold air. So in the winter months we have the westerly jet stream which creates high pressure over the Tibetan plateau, which we have seen when we were discussing the seasons. And in the summer seasons we see that we have the limb which is the easterly jet stream, which actually pulls the monsoon into the subcontinent. Hence we also see that the path of the monsoon follows the direction in which the jet stream is blowing. Similarly, the westerly disturbances which come from the Mediterranean to the Indian subcontinent, they can only travel so long from such a far distance is because of the fact that the jet streams blow in the form of vacuum cleaners. So, I hope the mechanisms for the monsoon are clear. So the monsoon regime takes place in the form of the burst of the monsoon, where there is all of a sudden the sudden onslaught of the monsoons, and sometimes between two wet spells, that means between two periods of very high intensive rainfall, we can have a break which is known as the break in the monsoon or a dry spell. This diagram is very interesting, as we can see the dates on which the Indian monsoons reach different parts of India. For West Bengal, we see that Kolkata receives rainfall around 7th of June. So the expected date and average date is the 7th of June. So for actually the Andaman and Nicobar Islands receive rainfall in around in May. In Kerala, it is in June, first week of June. So sometimes we hear this that monsoons have arrived in Kerala, which means that monsoons are coming to the northeast. So Assam will receive rainfall. If the rainfall has been received by Assam, then next it will be that Kolkata will be receiving rainfall. So the weather department can predict the rainfall according to the path or the date line which the monsoons follow. So this is an average dateline where we see that the parts of Rajasthan is 15th of July when the entire Indian subcontinent receives the monsoon winds. This is the withdrawal of the monsoons, which we will be discussing in details. We see that from September onwards the monsoon starts withdrawing. The western parts and the northern parts of India, the withdrawal is the first experience, And then finally in the south we see that the withdrawal is at the last. So it's 15 December for parts of Sri Lanka. It is 1st December in and around Chennai, and from September to December we can see that the monsoon is slowly withdrawing or retreating from the subcontinent. Now we go into the retreating monsoon season. As we have already seen, it begins from September to December, and the retreat is again gradual. It is not a sudden process. The average temperature is around 20 degrees Celsius, because soon after this we see that the winter season will start. High pressure systems start developing over the northern parts of India, and sometimes low pressures leading to cyclones can develop over the Bay of Bengal. So intensive cyclonic depressions sometimes can be created over the Bay of Bengal, and we have seen in the month of October, November, intensive tropical cyclones getting formed over the Bay of Bengal. So this is similar to a thunderstorm, but the intensity of these tropical cyclones is much more, and they are much more devastating in nature. And these storms originate in the ocean. Now we'll come to a part of the syllabus which is related to the seasons, which is the rainfall pattern of India and the variability. So we will be talking about the rainfall pattern. What is the pattern? So certain parts of India receive heavy rainfall, certain parts receive scanty rainfall. So we have the eastern part which is receiving excessive rainfall than the western part. The Deccan Plateau receives more rainfall than the coastal, receives less rainfall, sorry, than the coastal areas. So the variability of rainfall, that is how much variation is there every year, this can be measured with the help of a statistical tool which is called the coefficient of variation. So coefficient of variation is standard deviation by mean into 100. This formula tells us that how much deviation from the normal rainfall is taking place. So if my normal rainfall of a place, the mean is around 50 millimeter, and in 1 year I am receiving 20 millimeter, my coefficient of variation will be the calculation which will tell me the percentage of deviation, or the percentage of how much difference is there, which has been removed from a scale and made into a percentage, which gives us an idea as to how much deficiency or how much excessive rainfall takes place in a particular area. Let us look at the map which gives us the annual rainfall pattern of India. As we have already discussed, the eastern part, the northeastern part and the eastern part of India is receiving high rainfall, and the western part and parts of the northern areas are receiving low rainfall. If we look at the Deccan Plateau, it is receiving less rainfall compared to Western Ghats. Eastern Ghats are still receiving less rainfall. The Western Ghats are very wet compared to the Eastern Ghats. We will be now talking about droughts and floods of India very briefly. What are droughts? When there is a deficiency of rainfall, it leads to a kind of situation where we see that there is crop failure, there is less water, there is loss of soil moisture. This is known as my droughts. Sometimes a break in the monsoon or certain factors can lead to drought-like conditions. On the other hand, when there is excessive rainfall, then we can see floods take place. Both floods and droughts are extreme weather conditions which can lead to harmful certain harmful conditions in the country, which can lead to shortage of food, which can lead to different kinds of economic failures, crop failures within the country, and the economy of the country can get very badly affected. So when we are looking at these droughts and floods, we have to understand the areas which are affected by droughts, the causes of droughts, the effects of droughts and the mitigation programs which are there for droughts. So the areas affected, we mostly see that the western part of the country is where droughts are commonly seen. The causes are can be because of many different types, but one of the reasons, climatic reason, is because of less rainfall, failure of the southwest monsoons, and also sometimes anthropogenic factors or human induced factors can also lead to droughts. Effect of drought is that it can lead to crop failure, it can lead to economic loss, and we have certain drought mitigation programs in the country which help to reduce drought like situations in the country. For example, planting more trees in drought prone areas to conserve the soil moisture, judiciously using the water which is there present in that area. These can be some of the drought mitigation programs which can be performed, like rainwater harvesting. Every way of conserving water can be used. Similarly, floods are mostly seen in the northeast and the eastern part of India, but nearly all the Indian rivers have been seen to be uh, flood prone. The causes of flooding, here we are talking about floods which occur due to excessive rainfall. So when there is excessive rainfall in certain parts of the country, we see flooding situations take place. Floods lead to a lot of devastation, like washing away of the houses, killing of the cattle, and destruction of agricultural land, and also standing crops. But floods are important and necessary, so it is a natural process which will take place, but when the devastation is too much, it becomes a hazard. Many mitigation programs to curb the curse of floods are also done by the government in order to give relief. Finally, we will come to the temperature and rainfall graphs, which are the last part of this chapter. These are combined bar and line diagrams. So when we have the two axes of a graph, so we have the y-axis and we have the x-axis. When we are measuring months on the x-axis and temperature and rainfall on the y-axis, we can create these bar and line diagrams. Rainfall, so if we have January, February, we mark the different months in this way, so on. We usually mark rainfall, measure rainfall in centimeter or millimeter, and we mark them as bar diagrams. So from the data which is given, we make bar diagrams. So if there a particular place receives 10 centimeter rainfalls in January, we use a scale. So maybe 1 centimeter is equal to 10 millimeter or centimeter of rainfall. So in this way, we will mark a bar which will be representing 10 centimeter of rainfall in January. So in this way, the rainfall graphs are usually colored in blue and they are represented as bar diagrams. On the other hand, temperature, usually measured in degree Celsius or in some cases in degree Fahrenheit, is mapped as a line diagram. So we have the data for again the 12 months. So for every month we put a point. For example, if the temperature of January is 20 degrees Celsius. So if we have a scale here, so maybe 0, 10, 20. So this will be my point marked in January. So in this way I will draw all the points and I will be joining this with a straight line. So this kind of graph which is talking about the temperature and the rainfall gives us an idea of the climate of the region. Now let us look at examples and this will become much more clearer for us. So we have the average monthly rainfall and temperature for the station Delhi. So as we can see that the rainfall is measured in millimeters. Okay, precipitation is written. It is measured in millimeters and it is plotted as the bar diagrams. So in January, the rainfall is less than 40 meters. It's around 20 millimeters. February also around 20 millimeters. It's lowest in April. It is just a little less than 20, also 17, 18. Again in November it's very very low. We see highest rainfall of around 166 millimeters in August. So this is because of the monsoons. Now let us look at the temperature. Temperature is measured in degrees Celsius. So in January, which is a very cold month, we see temperature is around 25 degrees Celsius and it rises to around, in May it is around 40 degrees Celsius, very close to 40 degrees Celsius, and then it again reduces during the monsoon months because of the cold. It becomes a little cooler because of the rains, and again it reduces in the winter season. So we have another example of another station. Um, the station name is not given. So we have the highest rainfall received, most likely this is Chennai. So rainfall is received, very high rainfall is received in October, November. So this is the time when from the retreating monsoon, Chennai receives very high rainfall. And as we can see that the variability of temperature is not there, because the highest temperature is in the month of May, which is around 30 degrees Celsius, and you can see that the lowest, which is in January, is 25. So the temperature difference is not there. As we know, Chennai experiences maritime climate, so temperature differences will not be there so much. Now, this type of questions have been asked in the ISC several times, and this is a very interesting question. We can see that there are two stations which have been marked here, station A and station B, and the temperature and the rainfall is given. So we don't have to plot the diagrams and make the climatic diagrams here, but we should be able to interpret the data which is given. If we look at the temperature for January, let us have a look at that. So we can see that the highest temperature is received, it's around 33 degrees Celsius in May, and the lowest is around 21 degrees Celsius. Let us look at the highest rainfall. Highest rainfall is around 20.4 centimeters and lowest is 0.1 centimeter. Let us look at station B. Highest temperature is 30 degree Celsius and lowest is 24.4 degrees Celsius. And rainfall, so rainfall is actually zero because we have these dash, so no rainfall, so zero rainfall, and highest is 61.0. That's very very interesting. So if I have to calculate annual rainfall for station B, I will be just, when I'm talking about annual rainfall, I will add up all the rainfalls for all the months. So January to December, I have to add up all the rainfall values which are given, and I will be getting the annual rainfall, because they have just asked that how much is station B receiving rainfall at the end of the year. If they ask what is the average annual temperature, which is the next question, and so this is annual range of temperature, but say if they ask the average annual rainfall, if this is asked, then it is annual rainfall divided by 12, because they are asking me about the average or the mean. rainfall. So I have to give an idea about what is the rainfall for the entire year, what is the average rainfall or average temperature for the entire year. So if I am told to write about annual rainfall, I will be adding it all up and I will be giving the value. If I am told to calculate average annual rainfall or average annual temperature, I will be adding up all the temperature or rainfall values and dividing them by 12. Next, we have a very question, which is the second one, which is annual range of temperature for station B. When we have annual range or range of temperature is calculated as highest minus lowest. So highest minus lowest. So in this case, it will be 33.9 degrees Celsius minus 21.7 degrees Celsius, and whatever is the answer is your range. That means what is the temperature differences which I experience for this particular station. If the range is very low, then the place is experiencing maritime type of climate or very mild Mediterranean type of climate. If the range is very high, then the place is experiencing continental type of climate. So if you're given two stations and if you're told to write down the reason, you can easily do so with the help of this kind of a data. So, which of these stations has an equable climate? Of course, station A, because if I look at the temperature ranges for A and B, they are more or less similar. Though the range is a little high in temperature A in station A, it is less so in station B. But if we look at the variations of rainfall throughout the year, we see that the rainfall is received in the station A is equitable. Throughout the year, some amount of rainfall is being received by this station. On the other hand, we see that in station B, rainfall is very scanty apart from the month of July when rainfall is being received, most likely from the monsoons. Throughout the entire year, we don't receive that much amount of rainfall. It's only in these 4 months that a lot of rainfall is being received. So in this place, the other months will be having drought like conditions. There is a chance. So living in station B is a little difficult than station A. So station A has a more equable climate than station B. So in this way, give reasons can be asked from this chapter, and it's very important that we reason them out sensibly with the help of the data which is given, and we write the reasons down properly. So important questions for the exam. Interpretation of climatic data or climatic diagrams. There are several questions given in the any standard ISC textbook. I would suggest that you please solve them because they are important, and they have come several times in the examination. So giving reasons for climatic phenomena like why is mango showers called mango showers, why does Mangalore receive less rainfall than Mumbai, why is Delhi more cold than Chennai. These kind of questions can be asked, so you have to know the give reasons. Short terms associated with various climatic phenomena, especially the monsoons, like break in the monsoon, uh, dry spell, wet spell. These types of short terminologies can be asked from this chapter. And of course, map pointing is important, where they can ask you to mark the course of the southwest monsoons. They can ask you to mark the Bay of Bengal branch, the Arabian Sea branch, and they can ask you to mark a region which experiences flood, another region which experiences extreme drought. They can ask you to show areas, mark areas which receives rainfall from tropical cyclones, which will be of course the eastern part. So you can mark Orissa, Andhra Pradesh and West Bengal and also Bangladesh. So write down HP over a high pressure area in winter. Very common question, has been asked several times. Write down LP or mark the low pressure area or in the summer season. Where will they occur? So we have the two low pressure areas, one in the Thar Desert, the other is in the Tibetan Plateau. So these kinds of questions can be asked from this chapter. So before I end this video, I would like to say that this chapter is very important for the ISC examination. Every year many questions come from this chapter, so when you are studying this chapter, please do it properly so that you know all the reasons, all the analysis properly. And if you have any doubts and questions, you can leave it in the comment section and I can then clarify it. And if you please like the video, if you find it useful, share it and subscribe to my channel, and see you in the next video. So thank you very much.